All right, today we're going to be talking about transforming lines. So we talked about graphing lines and we talked about translations and rotations. Today we're going to be kind of doing those two things to the line. So we'll graph them and then we'll translate or rotate them. Okay, so it sounds more difficult than it actually is going to be. It's actually pretty easy. So first of all, let's start by looking at number one. It wants us to graph the line y equals x. So remember, if there's no number next to the x, it's just a 1/1 slope. If there's no number adding or subtracting to it, it starts at nothing, which is 0. And then we'd go up 1/1 to graph our line. Okay, so that is our original line right there. Now it's wanting me to translate that line 2 units to the left and 3 units up. So basically from each point on that line, I'm just going to go 2 to the left and 3 up, kind of like when you did that from each point on the shape. And again, you'll notice when I do this, it's kind of the same line, just moved to the left 2 spots and up 3. In fact, it still has that 1/1 slope. So when we look at this, these two lines, are they ever going to touch? No, they're parallel, right? They're two parallel lines, and you guys can see that a little bit when we talk about the slopes. The slope of the original equation was 1/1, and the slope of the new line was also 1/1. Okay, so both of them had the same slope. Let's look at another example. Let's try going to number 2 here. This time it wants me to graph the equation 7/5x minus 2. So again, before I start, the slope of the original equation is 7/5, so I'm just going to write that down. Okay, and then to graph a line, you always start at the y-intercept, so -2. And then we just plot out our slope, so it's 7/5. So rise over run, up 7/5. There's one dot. Can I fit the other dot if I go back 7 to the left 5? Like, no, it's not going to fit. So those are the only 2 dots that fit. So I just graphed that line right there. So now it wants me to take that line and translate it 1 unit down. So from each of those 2 points, I would just go down 1 spot, and there's my new line. Okay? If you look at those, are they ever going to touch? No. They are again parallel. And if I look at the rise over run, I would go up 7/5 to get to the other point. The new line is still 7/5. So basically the moral of the story is anytime you translate a line, it's going to produce the same line just slid over, right? That means that they're going to be parallel lines and they're going to have the same slopes. Okay? Now let's talk about rotating lines. So when we rotate a line 90 degrees clockwise, we're going to start off by graphing it just like we did before. So again, the original slope is right here in the equation. It's -3/2. So I'm going to start by writing that down. Okay, and then let's plot it. So starts at -3, and it's going to go down 3, 1, 2, 3 over 2. Or I could go backwards, go up 3, left 2. And I can do that a few times. Okay, there's my original line right there. Okay, now it wants me to rotate it 90 degrees clockwise. So clockwise is going to the right. So again, if I rotate it, this top part should be in the top right corner when I rotate it 90 degrees clockwise. So when I do that, there is my rotated line, what it should look like. Now all I'm going to do now is I'm going to just graph this line again. I'm going to pretend this is the y-axis and this is the negative and this is the positive. So I'm just going to graph it directly onto this scale here. So -3 is where it starts, and then I'm going to go down 3 and over 2. So down 3, 1, 2, 3 over 2. Or I could go backwards, left 3 over 2. And there is my line rotated 90 degrees clockwise. And if I rotate it back, you should see, again, the key part of this is when these two lines intersect, they should be intersecting at exactly 90 degrees. Okay? So let's look at this again. So let's try doing this one, except for we'll go 90 degrees counterclockwise. So let's plot it. So it's starting at 5, and there's no number next to the x, so 1/1 slope. Starting at 5, going up 1/1 or down 1, left 1. There is my original line right there. Okay. Then going counterclockwise, gonna rotate my paper to the left, and then I'm just gonna plot it again. So starting at 5, going up 1/1 or down 1, left 1. There is my new line, and you can see it right there, because I did that one a lot straighter. That is intersecting at exactly 90 degrees. Okay, so now that I've done that, let's try and figure out what happens to these two slopes. So what I'm going to do is I'm going to look at these two, I guess, points right here, or I can look at these 2 points right here. So if I look at these 2 points, let's plot out my rise. So it looks like I go up 2 and over 3. So positive 2/3 slope would be the slope of the new line. If I look at this one, looks like I go down 1, or right 1, down 1, so 1 and a -1, so it would be a -1/1. And really what ends up happening with these perpendicular slopes, if we look at these two new slopes, basically all that we do is we flip. So it was -3/2, right? So we flip them and change the sign. So it became positive 2/3. And that's all you're doing with perpendicular slopes, is you're just flipping them, changing the sign. Okay? And you'll see that as you graph all these and keep going. Okay, that's all we're doing today.